Today we're going to talk section 4-6, statistics, scatter plots, and lines of fit. So in higher level statistics, this can be a bit of a challenge, but we're going to take it very simplistic and keep it to the basics. So let's get started. So first, a scatter plot is a graph in which two ordered sets of data are plotted as ordered pairs in a coordinate plane. So you can have a bunch different types of scatter plots. If you have a positive correlation, the points, essentially you can see a positive slope line formed through them. A negative correlation will have a line formed through them in a negative fashion. And if there's no correlation, you can't really tell how the coordinates are set. So there's literally no way to tell which way the line would go through them. So that's what we're going to be looking at today. All right, so let's get started. So determine whether the graph shows a positive correlation, negative correlation, or no correlation. If a positive or negative correlation, describe its meaning. So as we move from left to right, we can look and see that it seems that there is a slight line, to the best ability, that we could draw through it somewhat like that. As it moves from left to right, it seems that it's starting to go up in some fashion. So it seems like there is a positive correlation. Well, let's spell that correctly. Okay, so given that there's a correlation of the data, it looks like as the number of fat grams goes up in fast food, the calories go up. So, oh, I don't know what happened there. As fat grams go up, calories go up. All right, so that's essentially what it's saying. Okay, let's look at another one. The graph shows the weight and the highway gas mileage of selected cars. Determine the graph shows positive, negative, or no correlation. If positive or negative, describe its meaning. So this one looks fairly obvious that, yeah, there's a correlation that we can draw a line and split it. It's not a very straight line, but it's a line that goes from left to right. So there is a negative correlation because it goes down. And what it looks like it says is the heavier the car, the less gas mileage. And we see this all the time. We see bigger SUVs having lower gas mileage than a compact car because they weigh less. Okay, so now let's do our own. So first, the table shows the vertical drops of 9 roller coasters in the United States and the number of years after 1988 that they were opened. So we're going to draw a scatter plot. So we have 151. So 151, I'm going to kind of estimate here. It's right about there. It's kind of hard to do it. And 3, 155. Not much higher than that. And then we jumped to 5, 225. And 8, 230. 12,306, and 12,300, and 12,255, and 13,255, and then 15,400. So there's our data approximately. Mine's not very good. But as we move from left to right, it looks like that the number of years after, it looks like the vertical drop seems to go up. So as time goes on, vertical drop increases. So then we want to draw a line of best fit the best we can. So we try to split the data as best we can, and there we go. So I just try to equal it out on both sides as much as possible. All right, let's do one more. So this table shows the estimate for the number of bald eagle pairs in the United States for certain years in 1985. So draw a scatter plot and then draw a line of best fit. Okay, so we have 3 years after 1985 and 2,500 pairs. So 3 and 2,500. And then we're going to go to 5, 3,000. And then we have 7, 9, 11, 14. So it kind of skips on us, but so 7 is at 3,700. So right about the middle there. And then 9, we have 4,500. So we got kind of a jump. Then we have 11 after that, remember, 5,000. Then we have 14 at 5,800. And then we have 15, 6,500. So this one is pretty straightforward. I mean, we can almost draw a straight line, but it's not quite. But I'm going to do my best. Like, that's not very good, but it's the best I could do given my ability on my computer. But there's my line of best fit. So yeah, it looks like there's a positive correlation as time goes on, the number of bald eagles pairs of bald eagles go up. So as time go on, as time goon, I guess, make that a little bit go. As time goes on, pairs of bald eagles increases. Okay, so there we go. So we're looking at data and seeing how it correlates with itself.